the Automated Podcast.
So welcome to another episode of Automated. As always, I'm your host, Marc Verbenkov. So I really hope that everybody's doing okay in whatever quarantine or lockdown state you find yourself in. As I mentioned before, it has been actually a lot easier to schedule and record interviews because everybody seems to have so much time on their hands now. So a few weeks ago, I was lucky enough to talk to Alkaios Bournias Varotsis, who is an expert on 3D printing and additive manufacturing. So you may recall that there was a widely shared technology news article where an Italian hospital had ventilators that were breaking down, and the suppliers were unable to make the needed part in time for the hospital. So a 3D printer was used to print the parts right there at the hospital, making the ventilators functional. So this event has actually led to a new wave of excitement for 3D printing recently, as well as additive manufacturing. And in this episode, Alkaios lays out the challenges and the interesting future that this technology has, while of course discussing the impact on jobs as always. So Alkaios is originally from Greece, but is currently in the Antler Startup Generator program, which is based in Amsterdam. So he spent 2 years as the technical marketing manager at an organization called 3D Hubs, where he published all the online technical content for their additive manufacturing platform. He holds a PhD in additive manufacturing from Loughborough University in the UK, and recently has been a freelance consultant supporting businesses in understanding the value that additive manufacturing can bring to them. So his work has also been cited by most mainstream industry outlets, including the latest World Economic Forum report on 3D printing. So I think it's really safe to say that Alkaios really knows his stuff when it comes to 3D printing, and I hope that you find this conversation as valuable as I did. So without any further ado, let's get into the conversation. Great. Well, Alkaios, great to have you here. Thanks for coming on to the podcast, especially during this surreal time that we're all living through right now. I think you're currently based in Amsterdam, right? How is everything going on during this crazy coronavirus outbreak time?
Yes, this is correct, and thank you for having me. It's been a few very weird weeks here in Amsterdam, and but I think that everybody's adapting to the new lifestyle.
Mm-hmm. Yeah, it's kind of the same.
Hopefully, it's going to be temporary.
Yeah. Same here. It seems like there was this really chaotic buzz that went on for a week or so, and now everybody's kind of settled into the lockdown lifestyle, and we're able to have interesting conversations like this a little bit more often, which I think is quite nice.
Exactly.
Yeah. So we talked beforehand that really due to this crisis, it's quite an especially interesting time for additive manufacturing and the entire space as a whole. I want to get into this a little bit later, but I kind of wanted to start by asking you what initially got you interested into the 3D printing and additive manufacturing space.
Mm-hmm. I started my career in 3D printing when I was still in the university about 10 years ago.
Mm-hmm.
And that was during the big hype about the technology, where it was when the patents were expiring and RepRap printers would change the global supply chains, and everybody would have a printer in their house, which turned out to be, well, wrong. It's not so easy to achieve this, and probably not realistic at all. But it was, I think, the promise of the technology of designing something in a digital aspect and then manufacturing it directly from a digital file. That was what initially got me excited about the technology.
Yeah, interesting. Very, very similar to myself. I was introduced to 3D printing about 7 years or so ago, and there was definitely this still the sense of the hype around the technology, which I still think exists to some parts in some places.
And don't get me wrong, we have done a lot of progress the last 10 years.
Mm-hmm.
And we went from prototyping applications and rapid prototyping to actually additive manufacturing applications, where we see parts used on real life high demand products.
Right, and this is kind of the transition from the kind of language of 3D printing, which was much more kind of a hobbyist language, to additive manufacturing, which is the industrial applications of it.
Exactly.
Yeah. So I've read that you've been consulting SMEs on helping to have them understand the full benefits of additive manufacturing, but you're now kind of pushing forward with launching your own startup and are part of the Antler Startup Generator program in Amsterdam, if I'm not mistaken.
Yes, that's correct. So I saw that there is a lot of potential in the technology, and I realized that there is currently there is a lot of opportunities of creating new products, new services, new um, businesses around this digital technology. And yeah, I decided to first try to consult other companies and eventually try to start my own venture around this. It's an interesting process. It's going slowly, but I think there's going to be a breakthrough.
Well, I'm very excited to hear about that. I was actually reading you've written a couple of posts about the program, and I was reading that you were thinking maybe initially about building a B2B solution where you would leverage data to solve problems kind of within the additive manufacturing field. Can you expand on that, or is this currently a secret, and you'll have to come back onto the podcast to share about that at some point in the future?
Yeah, let's keep it for the future because at the moment it's a little bit a lot of things are uncertain, and it would be better not to discuss something that might change because startups in the early stages pivot quite a lot.
Of course, no problem. I also would assume that due to the crisis, things are even changing more than usual. So, no worries. So, I think that you've expressed that you're quite passionate and you're also well situated within this field, within this industry, to talk both about the challenges, but then also kind of what we really want to focus on today, the future of additive manufacturing and what it might look like in certain fields. But maybe we can look at the challenges first, Hans. So you discussed the hype surrounding additive manufacturing. So why isn't this technology used everywhere yet? Perhaps you can just focus on those challenges first.
Yeah, so well, what the additive manufacturing, well, the 3D printing world realized
Mhm.
after the hype was that it takes more than just pressing print to manufacture something that is going to be used in different applications. So you cannot essentially, you need some certain certification and quality control because if something goes wrong, then there might be other implications. And these are the main two challenges that the industry is currently facing: certification and quality control. And the technology, from a technical perspective, is there today. You can manufacture a lot of end-use parts for functional applications that they serve the needs of the market better, whichever market you're in, whichever industry you're in. However, the cost of qualifying the process and ensuring that um, the part that you make, the first part that you make, is the same as the thousandth part that you're making, that is still the topic of discussion at the moment.
Right, because I would assume that this is able to be done with the current manufacturing processes that exist right now, but 3D printing might not be there yet, anyways.
Not exactly. We have already done it for the current manufacturing processes. But in order to replace a manufacturing process, you have to do the qualification step again. And that takes time and it's expensive. And that stops a lot of initiatives, the initial cost of investment, which, yes, it is cheap to make a single part.
Hmm.
However, in order to make a single qualified part would take at least months and a considerable investment.
Okay. Okay. Yeah, that does sound like it would be quite a limitation on moving things forward. Um, so one of the kind of more, and maybe this is one of the reasons that that you came on as a guest, was there's a viral story kind of coming out of Italy, one of many during this crisis period. But
Hmm.
it's about a hospital teaming up with a local 3D printing business, and they started to print valves that were unable to be
Yeah.
supplied for the all-important ventilators that we've been kind of inundated with.
Hmm.
So those people, from last I've heard, are actually now being sued by that valve supplier. Is this perhaps part of the problem of the additive manufacturing space, the IP concerns, as part of that
Um,
thing that you were discussing?
Yes. So, if I'm mistaken, the companies initially threatened to sue uh, the the people who took the initiative, but later they retracted this. But because I assume they had a huge PR backlash,
Mm-hmm.
and yeah, IP concerns are uh, some issue. I will touch upon it in a second. But first, about the story that you mentioned.
Mm-hmm.
These guys made a lot of things correctly. So what they did is they did not release the STL file. They did not publish it online. And they just kept it for internal use. And what they actually recommend now is to, before you start printing, first uh, contact the supplier, the local supplier, and after you confirm that they're out of stock, then place the order. That is what they are currently recommending to the other the other hospitals that are thinking of doing something similar. And also something important, they used industrial 3D printers, and I've seen some images online of this valve that is printed with what looked like a tabletop FTM printer,
Mm-hmm.
but in reality, what they're using on the hospitals is coming out from industrial grade SLS or MJF printers, which they use totally different process and totally different materials to create the parts. So
Okay.
yeah, there is much. There are a lot of more layers to the story than what uh, first was published in the media.
Yeah. Yeah.
And related to the IP concerns, that is something that has been discussed quite a lot in both the industry and in the academic lawyers have talked about it quite a lot. And there was actually a very interesting book by a professor in Cambridge University that was dedicated to these concerns regarding IP and digital manufacturing. So the main thing that you should consider is that we've been here before. In the early 2000s, there were a lot of similar laws, law cases regarding IP in music and other industries that were digitized. And 3D printing, along with the other digital manufacturing processes, are doing something similar to the physical aspect. So in my mind, what 3D printing does best is connecting the digital space with the physical space. And when you do this, you face a lot of the same challenges that you would face when you would share an MP3 file, for example. And I don't think it is a challenge from a technical aspect. And
Mm-hmm.
I don't think that this is something that should be in the top of the mind of somebody who's thinking about using the technology. There are solutions around it.
That's really interesting. I haven't heard before the connection between kind of the early 2000s and the streaming or the copying of music with 3D printing, but it makes perfect sense. One maybe final point before we move on this with the IP concerns. There was I think it also went viral several years ago and may have been kind of at the peak of the hype curve for 3D printing. And this was the 3D printing of guns. Right? I think there was, I believe it was called the Liberator, which was the one that got the most amount of press. Um,
Yep.
does that have a significant, or is that kind of the main significant difference between the copying of, say, audio files and copying of real life materials, in the sense that you can have a weapon that can be transmitted around everybody, whereas with a music file, I mean, you can not necessarily do that.
Um, well, there are some concerns indeed, but on the other hand, it's not 3D printing is not the only process that can be used to make something like that. I mean, if somebody would be really motivated to create this gun, you can use hand-carved tools and other manual tools to create it. So the case is, how easy do you make it to build something like this? And the question is that it's not that easy. The Liberator gun that you mentioned, I think it can only fire 1 or 2 bullets before it breaks, and most of the times it causes more damage to the user of the gun than the actual thing or person they are trying to shoot at. So it's not that easy to use a desktop 3D printer to produce something like that. If, of course, if you would go to like a metal 3D printer,
Mm-hmm.
maybe you could do that. But on the other hand, these machines cost a few $1,000,000, and I assume that the people who have access to these machines would not, um, well, be very willing to produce something that is illegal.
Yeah, it seems like it would be significantly more trouble than it's worth. Okay, well, that's really interesting. So kind of one of the main reasons that both of us wanted to talk today was really looking at the global pandemic crisis that we're dealing with, and how this might be used as a launch pad for additive manufacturing, specifically within the medical equipment supply chains that we've been hearing about, with the viral story coming out of Italy, and also maybe the understanding of supply chains that many of us may have never even thought about before, right? We now see grocery stores that are becoming empty, and we hear about all
Mhm.
these stories of masks and other equipment within hospitals becoming unavailable for people to use. So maybe you could
Mhm.
elaborate on this idea a little bit more.
Yeah, that's a great question. Actually, it has been great to read about all these initiatives and see all these initiatives taking shape around 3D printing, and how the community can help to solve these shortages in supply chain. And I've read a lot of stories in preparation of our chat, and
Hmm.
it's been very well, inspiring in a sense. You see the big players are raising funds in order to finance this the manufacturing, and or they are dedicating their equipment, and they are changing the supply chain in order to um, accommodate the production of this kind of part. So for example, Smile Direct Club, these they are making dental aligners, and they've invested quite a lot in industrial grade 3D printers. And now they are changing very fast their supply chain. They're changing the production, and instead of tooling for the dental aligners, they are creating well masks, face shield masks,
Hmm.
which is great. Or another interesting story was a company from China, the Winsun. They are using well, additive manufacturing to create buildings, and they created these um, quarantine booths to expand the capacity of Chinese hospitals. Or Carbon 3D, they started creating the test swabs. Um, which there are a lot of initiatives. It's around 3D printing and the pandemic situation, and it feels a little bit like a global hackathon of how can you use the technology.
That's really interesting. Yeah, it sounds like a very inspiring move where there's this shift in production capabilities to kind of manufacture something in a very flexible way, right? Is that maybe one of the ideas that people are starting to understand about additive manufacturing capabilities, that you can really switch your production capabilities very quickly and produce something like masks or like these quarantine booths that you were saying? How long would that shift take for these companies, if you know?
Well, minutes. You could have a build where you make this tooling for your organization, but in the next build, a few hours later, you could creating this kind of masks. Or if you have different kind of setups, just a few minutes later, you retool, you create the file digitally, you prepare everything in a digital fashion, and then the machine doesn't really care if it's making um, aerospace parts or medical equipment. It's the microfactories. Every 3D printer is a microfactory, which can change production extremely fast. And yeah, you're right about this. This is the capability of changing the production is one of the key aspects of 3D printing. However, there is a limitation, which is the production, the cost of producing a lot of mass production. And there are some economies of scale at 3D printing. So if you're making one, it's going to be more expensive than making 1,000. However, it does not scale as fast as other traditional technologies. Injection molding, for example, as when you have made your tooling, then essentially the rest, the parts that you make parts for free. We just have to pay the material cost, which is a few cents in the change in the when we're talking about injection molding. However,
Sorry, could you just maybe explain to those people that might not know what injection molding is, just a very quick description of it?
okay, so yes, in additive manufacturing, what you do is you start with an empty build platform and you add material layer by layer in order to build a part. In traditional manufacturing, in this case, that is formative manufacturing or injection molding. This is the most used technology to create plastic components. What happens in injection molding is that you have to create the mold, the tool, which has the negative of the part that you want to manufacture. And then you inject plastic, molten plastic inside it. The process of injection takes a few seconds, so you can make thousands of the same part in, in a few minutes, in a few hours.
Mm-hmm.
However, creating the mold is challenging. It takes time and it takes specialized knowledge to create a mold that produces the parts that you need. So in order to retool from one production to the other, it takes a few weeks. And this is where additive manufacturing comes in. You can retool from one production line to the other in a matter of minutes. And yeah, 3D printing helps in the pandemic crisis. It's not going to be the answer in the long term. If you want to create hundreds of thousands of these parts, traditional manufacturing will be more efficient in that way. However, when you have very high spikes on demand, 3D printing offers flexibility that no other traditional manufacturing process can offer. And this is why we see so many initiatives around this process at the moment.
Right. So this is why maybe the kind of medical equipment supply chains are really being supported by these different examples that you were giving. So additive manufacturing companies are able to switch within minutes, as you were saying, from building whatever they were doing before to the medical supplies that are needed in this current crisis, and potentially in future crises or other peaks of demand that you were mentioning.
Exactly. So in traditional manufacturing supply chains, you have to plan ahead for at least a few months. It takes 2 to 9 months for traditional manufacturing to produce a new product. while for additive manufacturing, as long as you have set up your processes, this can happen in a few days maximum, and then you're going full production for this new part, or multiple of different parts at the same time.
Right, right. Okay, so do you then think that with this crisis, with understanding that there's this incredibly flexible and fast turnaround for additive manufacturing, do you think that more organizations and maybe even more countries out there will start to consider additive manufacturing when they're maybe planning their future crisis scenarios, or in other ways that additive manufacturing can be useful?
Certainly, I think that this situation has played an important role um, to for the decision makers to understand the capabilities of additive manufacturing. We see, uh, for me, what is happening at the moment. It is a global case study on what can happen when supply chains go wrong, and we saw how this new digital technology can be used to solve this kind of supply chain issues. And when I'm talking about 3D printing, and additive manufacturing, I actually include all other digital manufacturing processes. Imagine also CNC machining, where you use a tool to remove material from a block, but it's controlled by a robot. So it is robotic manufacturing. It's controlled by software. And this is another digital manufacturing process. Or robotics also in general can automate a lot of the manual work that is needed to create parts. And what we see now, maybe because of the panic of the pandemic situation, but we see quite a lot of countries considering bringing the production, at least for strategic components, back within their national borders. And I've found some articles online, both from the side of the US, but also in Europe, talking seriously about this.
Mm-hmm.
And this is it's an opposite step to the global supply chain that we've been working in the past. And it has its benefits and limitations, actually.
Can you go into those a little bit further?
The benefit of globalization is that you can have the best manufacturer of the machines located in Germany, the best designer located in the US, and the best producer of the actual product in Asia.
Mm-hmm.
And that means that you get the uh, the best performance from each of these the knowledge of expertise of each of these companies. However, if you would bring everything in the same location, then you might have to compromise with some subpar solutions in terms of cost or quality. This is the argument that people that support globalization give.
Mm-hmm.
On the other hand, if you create something, maybe not in the same country, but near the same country, for example, if you are in Europe, just produce, maybe not in the Netherlands where I'm based, but in Spain or in Portugal. This gives you a lot of more flexibility in order to shorten this lead time from 9 months that it would take, for example, if you were producing in Asia,
Mm-hmm.
to 2 months. And that can give you a lot more flexibility in your planning. And of course, if you integrate uh, additive manufacturing together with traditional manufacturing, you can get you can take into account these spikes in demand. So what I see in the future happening is that we're going to use um, traditional manufacturing to produce a baseline of production, something that is safe and we can predict, that is coming in the future.
Hmm.
And we are going to use digital manufacturing processes, including additive manufacturing, to take into account the spikes in demand or the late stages of product development. And this is quite similar to the way that the energy grid is managed today. So, for example, we have the renewable sources, solar, wind. These produce energy only during certain times during the day. So, for example, solar panels can only produce energy during the day, and wind turbines only when it's windy. However, in order to serve the demand, you have to have a base production of energy, and that comes currently from more traditional factories. In the same way that renewable energy is going to supplement the energy grid, the same way additive manufacturing is going to be used to supplement existing manufacturing processes and supply chains.
Okay, very interesting. So as I see it, this is kind of fitting in within this reshoring trend, right? Where different nations have globalized their production all over the world, mostly in Asia, and now they're starting to bring it back to their own national borders. And you're saying that additive manufacturing is going to be one of the many, but also maybe one of the key technologies to enable this,
Mhm.
specifically because of this global crisis, making people aware that the supply chains are incredibly weak when they're stretched out across the world, and that it takes a long time to have one product from the design to it actually being produced. It takes a significant amount of time.
Exactly. And it will open up new opportunities that were not existing before. And I have two examples in mind. One
Please.
is customization. So we see a lot of applications coming up now in the space of, orthopedics, orthotics, and similar devices. And these need to be, or even hearing aids.
Hmm.
And these need to be adjusted to the physiology of the patient. And they are similar, but all of them are unique. And that is something that additive manufacturing can do much better than any other manufacturing process at the moment. Well, the alternative is to make it by hand, but that is very expensive.
Right.
And that customization comes up also in more industrial applications. One of my favorite examples comes from the copper inductors, and these are devices that are used to heat up metals. They use inductive heating, so they use electromagnetic waves to heat up metals. And in order to have best efficiency, you need to customize the shape. And there was a company who actually not only produced these custom shaped inductors tools,
Hmm.
but also they created a web application where a customer could just go online and customize the part that he wanted, and they would make it for them. So it is truly an on-demand and custom manufacturing, depending to meet the needs of the specific application.
Right. This seems also like where the demand from us consumers is coming or going, I should say. Right. There's this constant need to have our products personalized to us. Right. We can't all have the same cell phone or the same computer or shoes, as you were saying. Right. The consumer nowadays needs to kind of identify differently from the other consumers, and by doing so we need kind of much more flexible production capabilities, and additive manufacturing might be one of those technologies that enables that to happen.
This is true, but I personally believe that the consumer market is more of a vitamin. It's nice to have rather than an actual business case. And I think that there are a lot more business cases that come from industrial applications. And there are opportunities in every organization to create something that is more efficient and more suited to the particular needs of the organization internally. and that can only be unlocked using digital workflows.
Okay, so I see that the time is kind of winding down here. Maybe we can shift the discussion a little bit, still focused on kind of the future impacts, but looking more at how this is going to impact jobs. So if we're talking about the kind of reshoring trend, I could personally see a lot of the typical manufacturing jobs that are done in these massive manufacturing plants in different parts of Asia, moving more towards the Western countries. Is that a good analysis, or do you see also other impacts happening because of this?
Actually, there are quite a lot of digital manufacturing factories popping up also in Asia. So there are going to be a lot of these digital factories, the automated factories popping up all over the world. And regarding jobs, I see two trends. One would be, of course, there's going to be a need of people that need to run the factories. So the people who would operate these kind of organizations, but also there is a greater need for designers, people who can actually take advantage of the benefits of additive manufacturing and digital manufacturing in general. And I feel that the most pressing need at the moment is for the designers. We need to figure out first what would be these applications and how can we train people to identify this kind of opportunities. And that is difficult. It takes time, and it is something that is radically different compared to the way that engineers today are trained.
Yeah, it seems like there's a shift towards certainly more higher skilled activities within this type of work. Um, One question following that: do you think that maybe in say 5, 10 years there might be another shift within this? Right. So this is the shift that we see now, moving
Mhm.
towards much more designer based work. But do you think that perhaps that with the utilization of certain artificial intelligence systems, that there might be some sort of ability to understand the work that the designers are doing, and that the
Mhm.
humans would be kind of maybe augmented, but then also maybe replaced within this designer work in the next decade or so.
I don't think that the human designer is going to get totally out of the picture. I feel what the trend I see happening at the moment is that there are these kind of AI tools and algorithmic tools in general
Mhm.
being created, that they are essentially there to aid the work of the engineers. And I feel that I believe that there is a very human aspect in identifying the needs and the basic business cases. This is something that cannot really be automated and replaced, because it requires human intuition. It requires well, uh, probably not in 10 years, but in 50 years, there might be a generic AI system that can do that for us. But I don't think that this is going to happen in the next 10 years.
Right,
What I
right.
see for the next 10 years is this kind of AI automated tools that aid the work of engineers.
Right. So we'll have the term that's used in the literature here is the augmented employee. So the engineers will become augmented. Their jobs might be transformed rather than focusing on certain tasks. They might give that to these AI systems and the algorithms, and they're able to maybe focus a little bit more on the, as you were saying, kind of the human intuitive nature that you need in the designing of whatever product that's being designed.
Exactly, and this is what is happening now with, for example, with generative design. What the engineer is doing is he's setting up the problem, he's defining the constraints, the boundary conditions, the use case, and then the algorithm generates a geometry that fits this kind of constraints, the application. and then the humans usually can select. The human user can select among the different proposed solutions, and then you can find the best case, the best solution by the help of the AI algorithms.
Okay, so not only does a human focus more on the intuitive task, but then their work will also become maybe more efficient or more, how do I say, focused than what they were able to do before.
Yeah, I mean, for me as an engineer, the aspect of designing something on CAD, yeah, it is fun and it is. I enjoy doing it, but it is more of an operational task. It's something that's repetitive,
Hmm.
and it wastes time. Where an engineer can add most value is identifying and defining the problems, and this is what is going to be the shift in the work that a designer is going to do in 10 years than compared to today.
Very interesting.
And,
Well,
and also
yeah.
there is another aspect that we will see more and more is the introduction of digital workflows. So we will see more of these examples of co-creation and co-design that is helped by uh, these automated systems. And it might not be based on AI, but um, just the fact that you can modify something using some sliders and design a CAD file that is manufacturable with the press of a few buttons without having this expert knowledge, that is also a huge leap forward.
Could you go back one step and maybe discuss a little bit of what this co-creation and co-design is? I'm relatively familiar with it, but within the
Mhm.
context of additive manufacturing, it might be interesting for some of the listeners.
Yes, definitely. So there is a very interesting company. The application is on board games. They are making figurines for tabletop games. And there, for example, you can go and design your own figurine. And the design process is easy. You just um, press a few buttons and then you customize the character, how he looks, what they are wearing, and what is their posture. And then they just you buy that as a consumer, and the company uses 3D printing to produce it, which is only possible because of the digital workflows that 3D printing is enabling. However, the core activities of the company is not on the 3D printing side. They are actually outsourcing the production. What the company itself is doing is they've built this interface, the web interface, where they are the connection between the consumer and the production. And this is the co-creation process. You are involving more and more the end user into the design of the part, and you allow them to make it, to customize it and co-create it
Right, right.
however they like.
So I could speak to this. So when I was younger, I have two siblings, and we'd play a lot of board games when we were younger. One especially Monopoly. So there was always a fight over who would get the car versus who would have whatever the other figurines were, right? So I could imagine nowadays in this co-creative process for the specific games that you were mentioning, like my siblings and I would be able to select whatever kind of figurine we want, and then there would be no fights in between us because it would be able to be customized to our own unique interests. Of course, this is a minor benefit, but I think for the younger people out there, this might actually be important.
Yeah, well, it's about the Dungeons and Dragons, for example, is reshoring. It's increasing in
Mhm.
popularity again, and the application that I had in mind was exactly for this kind of games. And yeah, exactly. You wouldn't get what comes out of the box. You would design what comes out of the box.
Right, and I think that also maybe for businesses, then you would this would increase their ability to sell whatever products that they have, right? Rather than creating some generic thing that you're hoping many people would enjoy or use, you can be absolutely sure that the sale would happen because you're creating something that's very specific to your end consumer.
This is called on-demand manufacturing.
Yes.
And the premise is first you sell and then you make. And this way you have much more predictive revenue. You don't have to invest hundreds of thousands of euros ahead of time to produce something that might or might not be sold. You have already made the sale and then you make it, which makes it much more attractive for a business model than the traditional manufacturing model.
Mm-hmm.
And also in the marketing, for example, there is a term called A/B testing, where they are testing two different landing pages, the design, the text, they're testing two different landing pages with different users. And they can only do that because, well, replicating is cheap.
Mm-hmm.
So imagine if you can test different designs with different users, but physical objects, not only a web page. Then you will be much more convinced that before you go to mass production, this is the particular design that you're going to commit a large capital to produce. This particular design is going to get sold.
Very interesting. Yeah, I see that we're almost at the end of our time or scheduled here. Maybe you could tell us about where people can find you. I saw that your website, Additivist, is currently being improved. But if people want to follow you or get in touch, as you're clearly very knowledgeable on the subject, where can people reach out and get a hold of you?
Indeed, my website is currently under construction, but I am planning, because I have quite a lot of free time now with the pandemic situation, I'm planning to work on it ahead of time. So yeah, additivist.com is my website. And the social media that I use the most is LinkedIn. And people can reach out to me at, Alkaios Bournias Varotsis is my full name. I expect this to be a little bit difficult for users to find, but I am sure that you can add a link on the description.
Yes, I'll have all those relevant links up on the show notes. Not to worry. Great. Well, thank you very much for coming onto the podcast and sharing your understanding of the current crisis as how it relates to additive manufacturing and also the future for it. I've greatly enjoyed the discussion, so thank you very much.
Thank you also.
So thanks for listening to this week's episode. If you want to support the podcast, you can leave a like or a review on Apple Podcasts or wherever you listen to your podcasts. If you want to get in touch, feel free to do so over Twitter or LinkedIn by searching for Automated Podcast. On the website, automatedpodcast.org, you can leave a comment on any of the episodes, read the transcripts, and look at the sources I use in all of these episodes. There are also blog articles and additional resources and information on this topic and podcast if you are looking for more. See you next week.
The Automated Podcast.